Hello everyone, Shreyas this side, and today we'll be dealing 6 most important graphs from the chapter Inverse Trigonometric Function, and it will help us in dealing the problems of the type f inverse of f of x. So, firstly, y is equals to sine inverse of sine x. The domain comes out to be all real, and the range comes out to be minus pi by 2 to pi by 2 for this function, right? Because for any real value of x, sin x will return the value minus 1 to 1, and then we have to invert this value minus 1 to 1, and for it the function must be defined, that is, the function can be inversed only and only if it is bijective. So in case of sin x, the function is bijective when we chop the entire domain of the real numbers into pi intervals. So our answer can be even pi by 2 to 3 pi by 2, 3 pi by 2 to 5 pi by 2, and so on. But we always prefer the principal domain. Now, coming to the periodicity, so after every 2 pi values, the value of sin x will always return minus 1 to 1, right? So for every 2 pi interval, the range of values is minus 1 to 1, and it repeats and repeats and repeats. So sine inverse will also repeat and repeat after every 2 pi interval. So the periodicity comes out to be 2 pi. Now, if y is equals to sine inverse of sine x, so sine y is equals to sine x. So y is equals to, now coming to the general solution, so the general solution is of the type n pi plus minus 1 raised to the power of n into x, where n belongs to integer. So in case if n is even, so it will be n pi plus x, right? And if n is even, we can also express it as 2m pi, right? So 2m pi plus x, and in case n is odd, that is 2m plus 1 pi, so it will return the value n pi minus x. So we can write it as odd pi minus x. So 2m plus 1 pi minus x, right? And since the periodicity was 2 pi, so we can say that after every 2 pi interval, the same thing will repeat. So y is equals to x from here, and in case of this we get y is equals to pi minus x. So we have break the function into two cases. We'll plot the graph for these two cases, and then we'll just copy it down for the other ones. So now the x value that was belonging to all real, right? The x value which was belonging to all real was chopped into the intervals of minus pi by 2 to pi by 2, right? Just so that our function be invertible. So for y is equals to x, so basically x belongs from minus pi by 2 to pi by 2. So in case of y is equals to x, the domain will be minus pi by 2 to pi by 2, whereas in y is equals to pi minus x, the domain will be minus pi by 2 to pi by 2 will get reversed and in a negative. So again it will be minus pi by 2 to pi by 2, and if we'll add more pi value to it, it will become pi by 2 to 3 pi by 2. Got it? Now we have to just construct the graph for this interval. So in case of minus pi by 2 to pi by 2, this is what you must get. And then in case of pi by 2 to 3 pi by 2, now this is an interesting one. If you look, so your function is y is equals to pi minus x. So in place of x you will put pi by 2. So pi minus pi by 2, that is pi by 2. So pi by 2, and pi minus 3 pi by 2 is minus pi by 2. So okay, and now you just need to repeat it, right? And so on. So I hope this is the graph for sine inverse of sine x. You got it. Now talking about cosec x. So cosec x is just the opposite of sine x, right? In sense vice versa of sine x is cosec x. So in case of cosec x, everything will be same other than the domain. In case of domain, you will find that not on all these real values your cosec inverse of cosec x will be defined, because 1 by sine becomes 0 at 0, pi, 2 pi, 3 pi, in sense n pi. So out of all the real values, n pi values will be excluded, and thus in case of minus pi by 2 pi, 2 pi by 2, you will observe the 0 value will be excluded. Similarly, pi by 2 to 3 pi by 2, the pi value will be excluded, and so on. So in case of cosec inverse of cosec x, the entire graph remains the same. The only changes arises is at n pi. So at 0 value will be excluded, at pi value will be excluded, at minus pi value will be excluded, at minus 2 pi the value will be excluded, at 2 pi the value will be excluded, and so on. So this can be the graph for cosec inverse of cosec x. Got it? And the white one is for sine inverse of sine x. And similarly, we'll construct the graph for cos and sec. So cos inverse of cos x is equals to y. So cos y is equals to cos x. Now the general solution comes out to be y is equals to 2m pi plus minus x, where m belongs to integer. Now since x takes all real value, so the domain is all real, and cos x repeat after every 2 pi interval. So cos inverse also had the periodicity of 2 pi interval. So the periodicity is 2 pi interval. So we can rewrite it as y is equals to x and minus x. Now for the function to be invertible, we chop the domain of all real into intervals of 0 to pi, right? So x belongs from 0 to pi for being invertible, and thus y is equals to x, so it will become 0 to pi. Now in case of minus x, we just need to reverse it by multiplying with minus 1, so it will become minus pi to 0, right? And now you just need to construct the graph for these two intervals, and you have to just repeat it. So zero, pi, and 0 to pi it is y is equals to x. So pi. Now minus x, so minus pi to 0, and minus of minus pi is pi, and minus of 0 is 0, so it will be something like this, right? And now you just need to repeat it. It is pi, so it will be 2 pi, it will be minus 2 pi, just repeat it, and so on. Now in case of sec x, that is vice versa of cosec x, cos x, the values at which cos x will be 0, that is pi by 2, 3 pi by 2, minus pi by 2, that is 2n plus 1 pi by 2, they will be excluded. So 0 to pi, you have to exclude pi by 2. Pi to 2 pi, you have to exclude 3 pi by 2. Minus pi to 0, you have to exclude minus pi by 2. and so on. So it will become the graph for sec inverse of sec x. And yep, these are the graphs for sine and cos and sec and cosec. Talking about tan and cot. So y is equals to tan inverse of tan x. So tan y is equals to tan x. And the general solution will be y is equals to n pi plus x. Very important. And in case of cot, the places where tan will be 0, that is 0, pi, 2 pi. So you have to remove it. So minus n, m pi comes. Minus m pi. So we'll see both of them. Like the periodicity of tan, if you see. So this is the tan x graph, right? This is the tan x graph. This is minus pi by 2 to pi by 2. It goes till infinity. And minus pi by 2 to pi by 2 is open, right? It is an open interval because it doesn't, it gives the value infinity at pi by 2 and minus pi by 2. So obviously the inverse cannot be defined. Now, so through the graph of tan x we find that the periodicity is pi. And in case of cot x also, if we see, the graph is something like this. So again, if you see, the periodicity is pi. So the periodicity is pi in case of tan x as well as in cot x. So since the periodicity is pi, so this n pi can be excluded and y is equals to x will become your function. So y is equals to x and x belongs from minus pi by 2 to pi by 2 for tan. So we just need to construct the function and then repeat it. In case of cot, the interval is 0 to pi. So in case of cot, you have interval 0 to pi. So y is equals to x, where x belongs from 0 to pi, and you have to remove odd pi by 2, right? Where the tan becomes no, I'm sorry. You need not to remove anything just because tan becomes 0 at 0, pi, 2 pi, and these values are excluded. So we need not to take care of the excluded values. Now let us just make the graph for tan and cot in one single page. So from minus pi by 2 to pi by 2, y is equals to x for tan, and that too open at minus pi by 2 and pi by 2. So yep, this is your graph. Now you just need to repeat it continuously. Just need to repeat it and so on. Okay, in case of cot, 0 to pi and open, yeah, 0 to pi open. If you know that cot inverse of x, 0 to pi open, right? It is invertible. So this is the graph and the value will be pi. Then again 0 to pi to 2 pi and so on. So you just need to repeat it. So this was the entire graph. This was for cot inverse of cot x, this was for tan inverse of tan x, this was for sec inverse of sec x and cos inverse of cos x, and this was for sine inverse of sine x and cosec inverse of cosec x. I hope you got each and every graph. Trick to learn, because these graphs must be on tips for solving the problems. So the trick to learn is very simple. You just need to take care of tan and cot and nothing else. Tan and cot. And the good part is that the interval is pi. The only interval is pi you need to care of. Like in case of sine and cos, you had the interval 2 pi, which was difficult to learn because your graph got breaked into pi intervals and of different shapes. Like one was of this shape, so other was of this shape. But in case of tan, you have tan and cot, you have the only single shape, which is this for every pi intervals. So you just need to learn the graph of tan and cot, and then you have to construct the other ones. So in case of tan, we had the graph like this, right? You just need to learn this. You have to learn this. So we had the graph like this in case of tan, right? Open both the sides, minus pi by 2 and pi by 2. Now in case of sine, you just need not to remove minus pi by 2 and pi by 2, because sine is defined. Sine is invertible at minus pi by 2 and pi by 2. So in case of sine, you have to just close it up. You have to just close it up. And since it is of the interval 2 pi, and you have just constructed a graph of pi interval, so you have to make another pi interval graph, and for that you just need to elongate the hill. You have to just elongate the hill. You have to just extend the hill shape. So for that you just need to push it down, and then again for further drawing you just need to again copy the shape, copy the pattern and everything. So this was for the tan and sine. And in case of cosec, you just need to take care of where the values of are not defined for the cosec. So sine is 0, so at 0, pi, 2 pi, 3 pi, the values are 0, so 0. And this is pi, right? This is pi by 2, this is pi, and this is 2 pi. So these places the values will be excluded. So this is a very good trick. Like in a hurry, if we see, we just constructed minus pi by 2 to pi by 2. For sine, we just elongated, closed the boundary ends. For cosec, we just removed the n pi values. Now talking about the graph of cot, cos and sec. So you just need to remember the graph of cot, and the best part is they are just of pi interval, not of 2 pi. So in case of cot, we had 0 to pi open. So 0 to pi open. Now just elongate it. In case of cos, you just elongate it and close the boundary values. So just close the boundary values and elongate it. Elongate the hill shape. So if you elongate it, it will become something like this, pi to 2 pi. Clear? And then you just need to copy it out further. Now in case of sec, that is vice versa of cos, the places where cos is 0, that is pi by 2, 3 pi by 2, 5 pi by 2, you just need to exclude those values, and these are those values, right? So you just need to open up these points, and that's it. You are done. So there is a very fast trick to construct the graph, all the 60 ratios, f inverse of f of x graphs. I hope you liked it. Signing off. We'll see you in next video with another good topic. Till then, take care. Keep